Our topic is propositional logic. Sometimes it is also known as propositional calculus or zeroth order degree. Let's first see the definition of proposition. A proposition is a declarative statement that either true or false but not both. Let's see the example. Let P is any statement, so check either P is a proposition or not. So our statement is New Delhi is capital of India. So this statement is true or false, whether a New Delhi is the capital of India or not. So that's why we can write this statement P is proposition. That's why we write here P. So our second statement is 1 plus 2 is equals to 3. Which is true. That's why it is also a preposition. Let's take another example. 4 plus 6 is equals to 9. This is false, but I have already told you if the statement is either true or false, in both the cases this statement is a proposition. So this is also a proposition, and this one is also preposition. So our fourth example is was the time. So in this statement we can't answer this statement with true or false. We have to give a time which is not come under true or false. That's why it is not a proposition. Not proposition. Our next statement is P1 is x plus 1 is equals to 2. So in this case, if x is equals to 1, then this is true, and if x is equals to 4, then it is false. So we cannot confirm say that it is true or it is either it is false. We So that's why this is also not proposition. So next example is P2 is there exists x which belongs to R such that x plus 1 is equals to true. Then answer of this is true, which is absolute, means the answer is absolutely true. That's why we can say this is proposition. So our next example is he is tall. He is tall. So we cannot answer this question in true or false, because he is a pronoun. He is a pronoun. He is a pronoun, and we are comparing it with whom. So for a shorter person, he is a tall, and for a very taller person, he may not be a tall. So this statement is not proposition. So our next example is this statement sentence is false. This type of example is also known as liar paradox in logic, because if the answer of this question is true, then the statement is false, and if the answer of question is a false, then the statement is true. That's why there is a possibility that true or false anything can be happen. So this is also not proposition. So our next topic is logical operator on preposition. So our first logical operator is, the first one is negation, which is unary operator. Unary means we can use this means this operator require only one operand, denoted by it is denoted by so let's take an example. Suppose P is an proposition and today is Friday. So negation of P is today is not Friday and it's not Friday today, and it's not the case that today is Friday. We can write negation of P in many of the ways, and these are some of them. So let's draw the truth table for the negation. Truth table. P, negation of P, and negation of P. Negation of P is same as P. So if it is true, then it is false and it is true, and if it is false, then it is true and it is true. False. So our second logical operator is conjunction operator. Conjunction. It is denoted by P, this sign, Q, or P dot Q, or simply PQ. Any of this can be used. If there are two proposition, first one is today is Friday, and second one is it is raining. It is raining today. So we can write P conjunction Q as today is Friday and it is raining today. Truth table for the conjunction operator is P Q, P conjunction Q. So it is in this case we have four cases. First one is FF, FT, TF and TT. FF will give if, F, F, this is T. It is same as NAND gate, because our next operator is disjunction operator, and disjunction operator can be denoted by this V symbol or plus symbol or logical or symbol. We can write it like P, like this, like this, like this. In C programming language, it is denoted by double, and in digital logic circuit we denote it by OR gate. So let's take an example. In the previous example, this is our P and this is our Q. So we can write P disjunction Q like today is Friday or it's raining today. And this is our truth table for the disjunction operator. So our next operator is exclusive OR operator. In DLC, we denote this operator as a XOR gate, and truth table for this operator is PQ and P XOR Q. If the both the input is same, then our output is false, and if both the input is different, then only our output is true. Let's see, true, true, false, true, false, true, false, true, true, and true, true, false. And we can write P XOR Q in the form of negation operator, conjunction operator, and disjunction operator. And we can write this like P conjunction negation of Q and disjunction negation of P and conjunction Q. And we can also this or this, both are same. We can also write it like P disjunction Q and again disjunction. So we are trying to denote P XOR Q in the form of negation, disjunction and conjunction. P conjunction negation of Q, then disjunction negation of P conjunction Q, and P conjunction disjunction Q and conjunction negation of P disjunction and negation of P. You can see that we can replace this by this, and the only difference is in when the conjunction is on the middle, then both the negation is on the right hand side, and when disjunction is on the middle, then there is one negation on the left side is, and there is one negation on right side.